Ref.
Yeah, it can be 0.
Isaac, can normal force be positive?
Well, what do you mean positive?
Can normal force be positive number?
Do you mean up direction or down direction?
Positive
the
number.
normal force can
That's all
only
I
be
can
down.
say.
Normal force can
No,
only be
positive
down.
means
He's trying to trick me. The magnitude is obviously positive, but
No,
he
no, no, no.
negative. Negative.
can
To say the
no, come on, you just don't cut me just because my English is bad.
Barry, please help me call this trickster out.
Can normal force be positive on the top?
Normal force cannot point upwards.
Good.
Good.
Why? Ref, why? Oh, no.
Because
You keep your mouth shut. Ref, why?
because if it's on the top, the normal force can only be down. It can only be
No,
down
the
because
question was, Brown
Yeah.
University, the question was why the normal force at the top at 90 degree cannot be positive.
it cannot be positive because normal force can only point down at the top.
Oh God, if it is positive, what would be the consequence?
Yeah, then it would go through it wouldn't be on the roller coaster. It's not possible for it to be
Then it will
positive.
break the loop
Yeah, it would go through the roller
and
coaster.
it will meet the God.
Yeah. Okay. Yeah.
Yeah, it will meet the God. It will just break the loop and it's gonna meet the God.
Yeah.
Okay, so it cannot be positive. Welcome to Bari Science Lab. From today, we're going to start a new series. We're going to call it Physics Teacher. And today, the episode number 1. And this is Raf Bari. He's going to join us from Brown University. He's a graduate student of physics at Brown University. And this is Suborno Bari. He's going to join from New York University because he is a math major and physics major at New York. Oh, he's here.
Hello.
How did you come here all the way from
I
New
live
York?
here.
Okay. All right. So that means your brother has to join from Providence. All right. Are you ready?
Yeah, I'm sure he can make the 4.5 hour drive here.
I'm going to give you a challenge and your brother, and I'm going to keep it secret. This is called Physics Teacher, episode 1. Let's see who wins. Can you wish your brother good luck?
Did you think of
Can you wish your brother good luck?
Did you think
Can
of
you wish your brother good luck? I know you are a selfless guy. I
Good
know
luck.
you are selfless.
Good luck.
Who do you wish him good luck? You or your brother? Guys, you ready?
Yes.
All right. So I'm going to have some challenge for you. Today, we're going to try to understand the vertical rotational circle. All right. Vertical rotational motion. Vertical circular motion. Let's call it vertical circular motion. Okay. So this is our vertical circular motion, right? Do you see it? Isaac, do you see it? All right, I'm going to ask you a bunch of a question on this vertical circular motion. All right. So if I put a roller coaster like this over here, right?
Mm-hmm.
And say roller coaster is like this. Okay, roller coaster moves counterclockwise. So far, so good.
Yeah.
All right. And roller coaster is 100 kilogram.
Okay.
And the velocity at 270 degree is 30 meter per second.
Okay.
So good. So I'm going to ask you a bunch of a question. We're going to explore 8 physical quantities. Number 1, velocity. Number 2, acceleration. Number
Okay.
3, normal force. Number 4, centripetal force. Number 5, I don't know.
Kinetic energy, potential energy, mechanical
Number
energy.
6, kinetic energy. Number 7, potential energy. Number 8, total energy. I am looking for another vector which is missing. What vector is missing, you think?
FG.
FG is missing. Thank you. So these are the physical quantity. Isaac, what is the definition of physical quantities?
Sorry, I'm not paying. I'm just kidding, of course. So a physical quantity is essentially any quantity that is physical.
Raf, what is the physical quantity?
A physical quantity is something that you can measure using one of the 7 SI units.
Good. So Raf, Brown, and NYU. Brown 1 point, NYU 0. Okay, so physical quantity is a quantity that you can measure in the lab. That's very nice. So out of this 8 physical quantity, Isaac, why you are losing attention? Are you distracted by
Sorry.
somehow? I cannot post this video online if you are distracted. Are you doing
No.
some funny business on the side?
I'm closing everything down because I have lots of applications.
We can see when your face brightness changes. It's obvious.
I
I'm
saw you are.
closing every other application down. What the hell?
Okay, all right, we are ready?
Yeah.
All right, so now how many of them are fundamental physical quantity, Isaac?
I believe only. I'm pretty sure none of them are fundamental assignment.
Okay, okay, very good. That's correct. And Raf, how many of them are derived quantities?
8 of them.
Okay, all of them are derived quantities. So we're gonna try to understand all 8. So to do 8, we have to draw 8 circle. Why are we gonna draw 8 circle? Because we have to. 1, 2, 3, 4, 5, 6, 7, and 8. So the first question is Isaac. Isaac, can you tell me over here, okay? 4 location we're gonna consider 1, 2, 3, 4. All right. So this is 270 degree. This is
0.
this is
90.
and this is.
180.
All right,
180.
let's first check the velocity. Isaac, at what location the velocity? We're gonna call 1, 2, 3, and 4. What location velocity is smallest?
Smallest should be 3.
That is correct. Okay, Raf, at what location velocity would be the same?
2 and 4.
That's correct. All right. So velocity and velocity.
Oh, that the number 4 should be the other way.
Number 4 should be other way. Very good. I was testing the Isaac, but okay. So velocity is gone. Now let's do the normal force. Isaac, at what location the normal force is greatest?
I personally think, okay, let me think for real. So then I have to think about at what point the velocity is the greatest because that determines the centripetal force. So the velocity is greatest at 1.
There's no thinking involved here. It's just, okay, I'm not going to say it.
I am going to punch you through the screen. My hand is going to travel 200 miles directly to Providence just so I can smack you directly in the face. Okay, now that that's done, it's 0.1.
All right, that's correct. But should I give you a point because the roasting brown university is like not good thing. Okay, so the normal force is a greatest over here. Excellent. So this was velocity. This is now normal force. Now, where is the normal force smallest?
3.
Yeah,
Point
very
3.
nice. Very nice. Normal force is
It's a
smallest.
genius. A genius, I tell you.
Okay,
Thank
and
you.
normal force are the same at location 2 and 4. Okay, after normal force, we're gonna go to the kinetic energy. Rap, where is the kinetic energy 0?
3. Oh, well, not 0. No. That's a trick question. Wait. There is no point where the kinetic energy is 0, but it's least at 0.3.
It's least at 0.3. That is correct. Okay, kinetic
Yeah.
energy is least over here. But where is the biggest, Ref?
At 0.1.
0.1 kinetic energy is biggest. Right. Okay,
Yeah.
so after kinetic energy, you're going to do potential energy. Isaac, where is the potential energy biggest?
Obviously, it's at 0.3.
All right. And where is the kinetic energy 0?
You mean potential?
I'm sorry, potential energy is 0.
You thought you could trick me, huh? It's at, well, it depends on where you define y equals 0.
Oh my god. He's gonna be try to be politically correct. It's just
We said
0.1.
that 270 degree.
Yeah, 0.1.
Okay,
Yeah.
0.1 potential.
I was trying to be technically correct. Shut up. You're not a mathematician. You don't know what it's like.
Oh, Isaac, you are far away from the camera, so you look like an ant on the Zoom. Okay, now
This
it's
looks
too
enough.
close. Too close, baby. All right. After potential energy, ref,
Mhm.
don't get it wrong. Centripetal force. Where is the centripetal force greatest? 1, 2, 3, or 4?
Where V is the greatest, so it'll be greatest at 0.1.
That's correct.
Like
Point
30
one.
seconds.
Centripetal force is greatest at 0.1 and the smallest at
At 0.3.
0.3 and the same at 2 and 4.
2
Okay,
and 4.
Isaac, don't get scared. This one is really bad and this one is really hard. Where is the weight is biggest?
Well, the weight is the biggest. Where the normal, well, the apparent weight is the weight. Wait, like actual weight or apparent weight?
mg.
He doesn't know the difference. Shiva, you don't know the difference.
I do.
Okay, what's the difference between inertial mass and gravitational mass?
Shut up. That's not the same thing.
Oh, okay.
Okay, mg is the same everywhere.
Okay.
Hey,
This guy thought he could trick me. This nasty little.
But technically, the acceleration due to gravity is smaller at the
oh
top.
no, don't talk about it.
Okay.
We have been to Dao and we were 5,000 meter above the ground and we fell same.
Oh,
Okay.
wow.
Okay. So what is next is your total energy. Raf, where is the total energy smallest?
It's conserved, so it'll be the same everywhere.
Oh, thank God you did not kill the conservation of energy. Isaac, this is the last and final question. So I keep the hard one for you. Acceleration. What is the acceleration greatest?
Well, the centripetal acceleration.
Yes.
Centripetal acceleration is greatest wherever velocity is greatest, which means it's just at 0.1.
Okay, that's correct. All right, Raf, I have a question for you. Where the passenger will experience weightlessness.
At 0.3.
That's right.
I know about weightless.
Because the normal force is the apparent weight. So if the normal force is almost zero, the passenger will feel almost weightless.
Isaac, where the passenger will feel heaviest?
Well, at the bottom of the loop.
Isaac, is this roller coaster? Okay. Raf, what is the G force at location 3?
You don't know that without the numbers.
Okay, I gave you. Let's see who can calculate it faster. I gave you velocity 30 at location 3.
Location 3.
Velocity 30.
Radius.
Oh, radius is 10.
Wait, by g-force you mean the weight?
No, fast find acceleration.
Oh, centripetal acceleration.
Yeah.
Oh, okay, v squared over r, but okay.
Yeah, that's just 90 meters per second squared, genius. It's 90. It's 90.
Oh.
Okay. So what is the G-force? What is the G-force?
The G-force is the G-force. It's 9 G's. It's 9 G's. Wait, no. It's 10 G's. It's 10 G's. It's 10. Wait, no.
No, at the 0.3, there is no normal force. So
No,
Did I ask 0.1 or 0.3? What acceleration did I ask?
0.3.
0.3 acceleration is not 90, Isaac.
What is it?
0.3 acceleration is 50.
How?
What? What do you mean how?
Centripetal acceleration is v squared over r.
No. Look, Fn, Fg. So F is equal to ma. So F minus Fg minus Fn is equal to minus mv squared over r. Or just Fc.
You find Fn by using.
So Fn is equal to m a minus g. A is 100. I'm sorry, m is 100. A is how much?
That's how we find that with v squared over r.
Oh yeah, acceleration. Okay, 90 minus what?
10.
So normal force is how much?
80,000 or 8,000.
No.
Yeah,
It's 8,000. He's right.
8,000 newtons.
So normal force on the top is how can it be 8,000? Where did I make mistake?
Yeah, it's 8,000. That makes it 8 G's because it's 8 times the regular weight of the car.
How did you get A is 90?
It's V squared, which is 900, over R, which is 10.
How did you know V was 900? Was that given?
It was given V is 30.
Oh, okay.
All right. So is how many G?
8 G's because it's 8 times the normal weight.
So Rap, is this roller coaster is safe to take?
No, because most humans survive 2 Gs maximum.
No.
No.
No. I think human can survive up to 7G or 8G.
Well, that's if you're a like fighter pilot. Then it's a different story. But
No,
normal.
Anyway,
everybody can
either way, I don't think this is safe for your average
Oh,
human.
actually, when you are taking off on a regular plane, I actually measured the acceleration with my phone, and
What is-
it's about 1.8 Gs
Oh
on
yeah,
a regular
because
plane.
all those babies and all those grandmas
Yeah.
are in the plane.
Yeah.
It doesn't feel like you're about to pass out and die when you're.
Imagine if you make a baby go at 8 Gs,
That's right.
Yeah.
So this elevator is not safe to take, right? I'm
No.
sorry, this roller coaster.
Yeah, to make it safe, you have to increase the radius, so V squared over R decreases.
Oh, speaking of making it a safe roller coaster, I'm gonna give you two problems. Let's see who can find it faster. Is the roller coaster is upside down? Is that right?
Yes.
Okay, yeah.
Mass of the roller coaster, let's say 5 kilogram. Okay, the radius is 2 meter. Okay, now can normal force be 0, Ref?
Yeah, it can be 0.
Isaac, can normal force be positive?
Well, what do you mean positive?
Can normal force be positive number?
Do you mean up direction or down direction?
Positive number.
normal force can
That's all
only
I
be
can
down.
say.
Normal
That's
force can
not
only be
positive
down.
means
He's trying to trick me. The magnitude is obviously positive, but
No.
negative.
no, can't.
To say
No, come on, you just don't cut me just because my English is bad.
Barry, please help me call this trickster out.
Can normal force be positive on the top?
Normal force cannot point upwards.
Good.
Good.
Why? Ref, why? Oh
Because-
no. You keep your mouth shut. Ref, why?
Because if it's on the top, the normal force can only be down. It can only be
No,
down.
the
because
question was Brown
Yeah.
University. The question was why the normal force at the top at 90 degree cannot be positive.
It cannot be positive because normal force can only point down at the top.
Oh God! If it is positive, what would be the consequence?
Yeah, then it would go through it wouldn't be on the roller coaster. It's not possible for it to be
Then it will
positive.
break the loop,
Yeah, it would go through the roller
and it
coaster.
will meet the God.
Yeah. Okay. Yeah.
Yeah, it will meet the God. It will just break the loop and it's gonna meet the God.
Yeah.
Okay, so it cannot be positive. Normal force
Yeah.
can be negative, and normal force can be 0. Is that right?
Yeah. Yeah.
You don't want to be in a roller coaster that meet the God, right?
No.
Okay. So you're gonna find. Okay, another question. Have you ever taken a road like
Send me
this?
some of the answers.
Huh?
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 Have you
What?
ever taken a road like this?
Yeah.
Like a car moves to 10 meter per second,
Yes.
and then it's car, and then car, and then car over here.
Mm-hmm.
Then the car normal force be 0 now.
Then the car over
Ah,
here.
yeah.
No, its normal force cannot be 0 because it's in contact with the ground.
This
Obviously.
one is contact with the loop, so it normal force can be 0. Why then this one cannot be 0?
It's literally.
Well, it's because okay. So in that case, in the roller coaster case, the normal
A,
force is
A
zero.
and B. Okay. B can normal force can be zero. Fine. It gives people sensation.
Yeah, yeah.
A, why A normal force cannot be zero?
We are on
B-
top of a hill, not in rotational motion.
No, that's not why. That's not why. In B, you are changing direction. You are going from up to down. Whenever you change direction, then the y velocity goes to zero. So that means the normal force has to go to zero. It's just like when you throw a ball up. The ball is going up,
What?
and then the velocity
If
goes
the
to
normal
zero.
force is zero, then this car gonna go to heaven.
Yeah, no, I'm saying in B, the normal force can be zero.
Okay,
Situation
good.
B.
Good.
Only because the car is changing direction.
Okay.
So just like when you have a ball that's going up, projectile motion, the y velocity is going to down, and at the top y velocity is zero, and then when it starts going down, y velocity starts increasing again. That's why in B normal force can be zero, but in situation A you cannot have normal force is zero because that means the car is not in contact with the ground. Whenever the car is touching the ground, it will have a normal force.
So then why
Yeah.
bike? Have you ever seen people people drive motorbike?
Yeah, yeah.
And Isaac, this question is for you. Have you ever seen people drive motorbike on the road? And have you seen the motorbike is off the ground sometime?
Mhm.
Yes.
And then a few moments later, they are back to the ground
Yes.
Mm.
because gravity pulled them down. So
Mhm.
why then Raf is saying that this when the motorbike is off the ground, okay, the normal force is zero. Then
Mhm.
nobody is die because of doing this type of funny thing on the road. But why you will die if the normal force is zero, but they're on the top of the hill?
If the normal force is zero, that means the hill is literally not holding you up at all. You're just gonna fall directly through the hill and get buried alive and die.
Oh, is this so, Raf?
If the normal force is zero, that means
The hill is not holding your weight.
Or is this because a few
no.
moments later, when normal force is no longer zero because pull of gravity, you're gonna be looking for ground but there is no ground.
Dad, do you understand?
This is when the normal force can be zero with the car. Here. So let's say you have the car, right? Here is the car. Right now there is a
Yeah,
normal
it's a
force.
flat surface. Normal force can be zero.
Yes. No. But then as soon as the car gets to the edge of the cliff, then the normal force will disappear over here. When there's you can
Well, yeah,
imagine this
because
is a cliff.
the
Yeah.
air can't hold your weight. If there's no normal force for the car on the top of the hill, that means the hill is like air. It's not holding your weight.
Yeah.
So you're
That's
gonna
right.
fall through
It's,
the
it's
hill.
just like it's just like when you have a box on the table. Okay, you are pulling the box at different angles. When you pull the box straight up, then the normal force goes to zero. But for all the other angles, there is still a normal force, even if
Okay.
it's
So the last
decreasing.
question is you're gonna yeah.
Um,
If you drop something very heavy on a very weak surface, then the weak surface will break open because its normal force cannot exceed the gravitational force of the heavy object.
so wait. Let me ask you a question. If the normal force is zero, does that we both agree the object is not touching the ground? But does
Yes.
that mean the object will go up or will it go down? Will it go into the object or will it go into the space?
Shouldn't it
What?
go down?
Because gravity pulling it down. What is it? Is this supposed to be a trick question?
Yeah, no, I'm thinking. Let me see. So if the normal force is zero. Let's
Okay,
see.
that's fine. We always can explore this question next time. But can you
Yeah.
go ahead and calculate the velocity at this location at 90 degree? Go. I give you 1 minute.
Oh, Oh,
The
the square root of
mass is 5 kilogram, radius is 2 kilogram. You're gonna find the velocity.
okay.
And Fn is 0, right?
Oh, Fn has to. You're gonna have to let Fn 0. Yeah.
Okay.
Okay, fine.
Isaac, show sometime at the end. You're gonna show your math.
Oh, it's easy. It's easy.
Oh, I got it. It's a square root of, oh, it's 10, 10, 10.
Is the square root of what? MGH? No. It's the square root of only G times R.
Yeah,
Wait,
it's 4.47.
oh,
Yeah, 4.47. Yes.
1 second, wait. Square root of 2G.
Rifat, what are you doing? You're finding the conservation of energy.
What?
You're using conservation of energy. How?
Yeah. So what? To get the velocity.
Rifat, are you kidding me?
Okay, how did you do it?
I did it by knowing that on the top of the. Can you shut up, Dad, for 1 second? The loop, the centripetal force is only provided by the gravitational force.
Oh, okay. Let me see.
I swear, this guy should be sent to a re-education camp.
So let's see. So V is square root of GR. So square root of GR. So
G is 10 and R is 2.
You're a little bit late, buddy.
no, but another approach, square root of GR. Now you can write down Einstein's field equation.
I'm leaving the meeting if you mention.
Now I'm taking GR. Now I actually know what it is.
All right. Okay. So we're gonna wrap up the physics teacher episode 1. All right.
What the Einstein-Hilbert action is.
Okay.
Of
All
course,
right.
I know what the Einstein-Hilbert action
All
is.
right.
If you vary the action, you get
All
the
right.
field equation.
Settle down, Brown and NYU. I know. Okay. The NYU, you don't have sound.
You find X. That's like saying if you solve the equations, you'll find X. That's literally the most vague answer you could have possibly given.
NYU, your sound is so bad. Okay, so this is folks, this is Brown University, and this is NYU, and you're gonna join us again on next weekend. All right, that has been the physics teacher episode 1.